Hi, so here goes our current voltage characteristics of a Zener diode. So you can see on the y-axis you have a current, and on the x-axis you have a voltage indicated by a capital letter U. So as explained in the previous session, we see that you keep on increasing the forward voltage. With a forward voltage about 0.65, the diode starts conducting a current and it increases exponentially as shown. And this is the normal case as it would happen in a normal silicon diode. And there is a current to voltage relationship. For example, at the forward breakdown voltage of a diode, you see that the current is about 1 milliampere. So you take this y value and you take this x value and see what's the current at that particular voltage. So that's it. So it is about your forward characteristics. How about your reverse case? For example, let's say your Zener diode has a breakdown voltage of 3.4 volt. So when you go to market and buy a Zener diode, in the data sheet you will have a breakdown voltage notification in that data sheet. So that's your spec, one of the spec of a Zener diode. So it can have a 3.4 volt, 5 volt, 7 volt, not much more than that. So it depends on what is your application. You choose a diode, and when you buy that diode and put it in a circuit, and the Zener diode will work in a way that you keep on increasing the voltage. Let's say you start with 0, then go to 1, then go to 2, and you reach up to 3.4 volt. So before you reach 3.4 volt, there is a very small current that is flowing here. As you can see, the very small current, that is a reverse leakage current. So we've seen that, and we know that the same amount of current the same way flows through a normal diode when it is reverse bias. However, in the case of coming back to Zener case, when it exceeds the breakdown voltage 3.4 volt, which is the specification of Zener, you see that the Zener breakdown, it is called as Zener voltage. 3.4 volt is also called as Zener voltage. That when that happens, when you cross that voltage, a current starts flowing in a large amount through the Zener. So you say that the Zener diode has been turned on, and when it is turned on, it lets the current flow from cathode to anode. Remember, we have explained that the current in a Zener diode will flow from cathode to anode. So this is your cathode, this is your anode, and the current flows in a reverse way, and it lets the current flow, and it holds that voltage of 3.4 volt across its terminal. So this is your positive, this is your negative. Let me use a different color to better explanation. So this is your positive, this is your negative, and you have 3.4 volt across the Zener terminal. Okay, and when that happens, it maintains that voltage across its terminal irrespective of the variations in the input current that is coming to it. Okay, but in case of a normal diode, the breakdown voltage is far bigger, like 50 volt, 30 volt, something like that. And when you cross that breakdown voltage in a normal diode, your diode will break down. It can, that heavy current damages the diode. That's called as avalanche in your normal diode, avalanche breakdown. Okay, so hope you understood the difference between the IV curves. Both IV curves in both Zener and normal diode look same, but the main point here is the concept of breakdown voltage, and after the breakdown, the Zener maintains the constant voltage drop across its terminals. However, That is not the case with normal diode. So property of Zener diode, as we've seen here, is used in designing references for variety of circuits in electronic design. And the property of Zener we just saw is also used to design a stabilized power supplies. Hope you like this video. If you did so, share with others, and please subscribe to our channel for more engaging content. Thank you. Wish you happy learning.